Section 10.2.19-T. According to a certain government agency for a large country, the proportion of fatal traffic accidents in the country in which the driver had a positive blood alcohol concentration, BAC, is 0.31. Suppose a random sample of 117 traffic fatalities in a certain region results in 43 that involved a positive BAC. Does the sample evidence suggest that the region has a higher proportion of traffic fatalities involving a positive BAC than the country at the alpha equals 0.05 level of significance? Well, first and foremost, to test the hypothesis, we first need to verify the requirements. That is, the sample must be a simple random sample. Well, first and foremost, we can answer that question because it says here that it was a random sample, so it is given that the sample is random. In addition to that, we also know that it can be assumed that 117 is less than the 5% of the total number of fatal traffic fatalities in a large country. Next, we want to be able to verify n times the assumed population proportion times 1 minus the population proportion, which is greater than or equal to 10. So let's go ahead and do that. Well, first and foremost, let's identify what n is. Well, n represents the sample size, which is 117. The population proportion is 0.31. Okay, so now what we're going to do is we're going to go ahead and plug that into the formula. N times the population proportion times 1 minus the population proportion, and we want to see if it's greater than or equal to 10. So we end up getting 117 times 0.31 times 1 minus 0.31. We want to check and see if that's greater than or equal to 10. So we end up getting 25.0, which is greater than 10. So therefore, all the requirements have now been verified. So now what we want to do is now we want to be able to figure out what is the null hypothesis and what is the alternative hypothesis. Well, remember that the null hypothesis, which is H subscript 0, is always going to contain the equality sign, which is the equal sign. And the alternative is going to have either the inequality sign or the not equal sign. Well, if we take a look here, we can see that it says, does the sample evidence suggest that the region has a higher proportion? So what it's saying here, that is the claim, and the claim always goes with the alternative. So therefore, the null is going to have the equality. That means that P is going to equal to 0.31. And therefore, since it says that it is a higher proportion, then the alternative, P, is going to be greater than 0.31 because, again, we're testing the proportion, so we're using the variable P. Okay, now in the next two steps, okay, these are additional steps, but when you're going through a hypothesis test, it's important to see what's going on. So in the alternative, we can see that it's a greater symbol, and if it's a greater than symbol, then we can say that this is going to be a right tail. Okay, and then in step number 4, we're also going to write out what is the significance level. So we're testing it at a significance level of 0.05. Okay, so now the next step is we want to be able to find our test statistic. So let's take a look at the formula. The test statistic is Z subscript 0. That's what we want to be able to find. In order to find that, we need to be able to figure out what this other information is. So this is the point estimate. We have our population proportion, and then we have our sample size of n. So let's go back up here. Okay, again, what it's saying here is that suppose a random sample of 117 traffic fatalities in a certain region results in 43 that involved a positive BAC. So what this tells us is that we know that the value of n is going to equal 117, which is the sample size. Okay, and what you also know is the value of x. Well, x represents the amount that's involved as a positive BAC, which is 43. Okay, and so we also know that the proportion is equal to 0.31. And so now we need to find the point estimate. Well, recall that the point estimate is equal to x over n, which is equal to 43 over 117. Okay, so now let's go ahead and plug that into our formula. So when we want to find z subscript 0, it's going to equal the point estimate, which is 43 over 117 minus the value of 0.31 divided by the square root of 0.31 times 1 minus 0.31 divided by 117. Let's go ahead and do this on the calculator. So if we take in parentheses 43 and divide it by 117, and then we're going to subtract 0.31. And then we're going to take that answer and just hit divide, and then we're going to hit second square root, and in parentheses, we're going to put in 0.31, close the parentheses. Parentheses again, we're going to take 1 minus 0.31, close the parentheses, and then we're going to divide that and then put that in parentheses, 117, and then hit enter. And we get, let's put this 3 decimals, 1.345. So this is approximately 1.345. So we're going to round that to 2 decimal places of 1.35. So therefore, there is our test statistic. Okay, now in this question, they want us to be able to find the p-value. So if we want to be able to find the p-value, okay, then what we need to do is let's take a look at what this bell curve looks like. Okay, so we want to be able to find the bell curve. So the bell curve is the following. Okay, we know that the mean is going to be 0. Okay, and again, it's a right tail, so we know that we want to be able to find everything to the right of this value, which is 1.35. So what we're looking for is this area here. So this is the p-value that we're looking for. Okay, so in order to find the p-value, what we can do is we can either use StatCrunch or we can use the calculator, which we've done in the past. So let's go ahead and take a look at the calculator. If we put in normal CDF, we know that our lower bound is going to be 1.35. We know that our upper bound is going to be 9999. We know that our mean is 0, and we know that our standard deviation is 1. Okay, so now what we want to do is we want to be able to put that in our calculator. So go ahead and let's do that. So second distribution, we're going to go to normal CDF. Our lower bound is 1.35. Our upper bound is 9999. We know that our mean is 0, our standard deviation is 1, and let's hit paste. And so we get the p-value to be 0.0885. So we have 0.0885. Now in this question, they want you to round it, I believe, to 3 decimal places. So it's going to be 0.089. Okay, now if we want to find a p-value using StatCrunch, then we would go to StatCrunch. Okay, and then we're going to go to Stat, select Calculators, and then we're going to go down to the normal distribution since we know that we're looking for the z value, so we'll select normal. Okay, we know that it's going to be standard mean, which is 0, and then standard deviation of 1. Okay, and we know that the value of that x has to be greater than 1.35. So therefore, that's going to give us our p-value with StatCrunch. Now, you could also use the table, if you would like we've done in the past, of your z-scores. Okay, now recall that if you wanted to use the z-score table, this is the area to the right. So if we take a look at 1.35, so let's take a look here. Here is 1.35. So here is 1.3. And then 5. And so you can see there that we get the z-score, the area of 0.9115. So if we take 1 and subtract 0.9115, let's go ahead and do that here. So if we take 1 and then subtract 0.9115, then we get 0.0885. So you have those three options to find the p-value. Okay, so now that we have the p-value, now what we need to do is we need to check. So our next step, number 7, okay, is to compare the p-value versus the significant level. Okay, so if the p-value is greater than the significant level, then we fail to reject the null hypothesis. If it is less than, then we reject the null hypothesis. So we know that the p-value is 0.089, and we know that our significant level is 0.05 from step number 4, and we can see that this value is greater than. So that means that we fail to reject the null hypothesis. And so therefore, now we need to state our conclusion. Okay, so here is our conclusion. Since the p-value is greater than alpha, you do not reject the null hypothesis and conclude that there is not sufficient evidence that the region has a higher proportion of traffic fatalities involving a positive BAC than the country.